Okay, I'm recording. Okay, so what is collection? You know about array, right? Array is an collection of similar objects. So similarly, a collection, as the word says, right? It's a collection of same elements. So that can be something like, let's say this is a team. This is a internship team of whatever the people, right? So that's a collection. Why we need this collection, right? It is easy actually, instead of calling you each and everyone, it is easy actually to group you as a member and calling you as a group ownership. So let's say, instead of calling you, right, did you guys understand, for example, simple layman English sentence, uh, is it better, or actually Sabha, did you understand, or like Kavya, do you understand, like each and every name, which one is better? Obviously, actually, team, do you understand, or calling you as a overall team, right? When it is a particular situation, calling you at the overall as a group of members is easy, right? So that's what actually, okay, the collection is very useful if you have actually storing or reading or manipulating the data. It may be anything, like let's say actually in yesterday's example, we learned about some student in the database. Actually, we learned about student table, right? It's easy, right? When we store similar information in one place, or we collect all the information, similar information in one place, it is easy to store that information in anywhere. Like it may be a file, it may be a database. If you store in same place, and it is easy to read also. Same way, it is easy to manipulate, means update the data or anything. Let's say somebody, maybe one of you maybe is very interested in collecting actually movie CDs. Somebody else may be interested in finding like a cricket data, cricket records. So likewise, right? It's all what we can do. Like a cricket records is a collection of data. Similarly, movie records, movie CDs or movie this one is a data. So they won't mix up two things, right? When you guys actually want to store that information somewhere, you won't guys mix up those things. You will actually store them separately. Okay. Think another way. You When you are going to a school, right? When you are going to college, when your second semester is completed, and uh, what will you do? You will take all the books and move to a shelf, a old shelf, and the new books will come. Either the third semester or the next semester's books will come to your daily use shelf. Why you do that one? Because it's easy. Because you are categorizing them as a collection of books, your notebooks, your textbooks, your assignment books. Actually, you are categorizing them, and you are keeping them in a same area, so that actually it will be easy for you to go to the college to pick whatever the books you want. That's what the next one. Transmit data from one method to another. So same thing, like your third semester is completed, then you will move all the books to a different shelf, and you will keep in another shelf for the old books. Okay. So data structure, methods, all these things actually, data structure is nothing but, again, we learned about a few things in the data structures, right? The linked list, trees and all, like how you can store the data. There are numerous ways how you can store the data according to your need. Okay. So all of you, like at layman words again, you all guys, okay, can be in a queue. If you all guys want to go to a movie, and you want to stand in a there will be a queue, right? So you all guys will stand in a queue. That is one way actually where actually I can keep all my people over there in a queue, or I can keep them in a row or row wise, right? First row 3 people, second row 3 people, third row 3 people. Likewise, also we can keep it, or round table, right? Everybody will sit in a round table and listen to that one. There are many ways actually how you people can like if I take only you 10 people, like I can give you different ways actually where you can sit and uh, listen to my tutorials. Similarly, data collection, data also, right? Collection of data also can be stored in many places. So as I said, right, it can be stored like a queue, it can be stored like a list. List is nothing but uh, your, okay, suppose actually your to-do list, or let's say like some of you actually are going to be married. Okay, what you guys do first? You will first put all the invitee list in a paper, right? What do you call that one? It's a list of invitees. So similarly, like any data, that element can be called, we can put in a list. And if you go to a movie, actually you will stand in a queue. That's also a collection of data. If there is one more concept similar to queue called stack, that's also the only difference in queue is you will be the first in, first out, whereas in stack it will be like a last in, first out. Whoever comes recently, they will be rolled up first. So likewise, actually, there are many ways how you can store the data. So and one more thing, how do you, if you want to do, if you want to draw a family tree, like how will you do? You will put everything according to your family structure, right? You are your parents are there, their parents are this one, and it comes like a tree structure. So the hierarchy structures are also a collection. All this one will categorize. We'll learn about all these things today. Okay. So now at least you got the basic idea, right? Why collections are very important in Java. Okay. Now let's see. Again, it's like a unified architecture of representing and manipulating data. As I said, right? Family tree. That's also a collection. What it holds, a member data of each and every family, of each and every member of your family, right? Your grandfathers and grandfathers, fathers, everything actually you will mention in the family tree. So what collection in Java, coming to Java, what collections actually generally contain? So collections are typically a interface, implementations, and algorithms. You can have interfaces actually is where actually they, as I yesterday I explained it, interfaces somebody develop for a contract, and they will develop so that actually you can use them in your programming as needed. Interfaces, implementation. Interfaces are the contract structure, like what need to be there. Okay. It's like a high level blueprint. If you want to let's say actually you are building a home. First, what will you do? You will first put where your blueprint, right? Where your um, dining area should be, where your living area should be, where your bathroom should be, where your bedroom should be, and all actually will put in a mark actually in a ground. Actually, you will put the marks where your pillar has to be and how it can accommodate your needs actually. The living area, bedrooms, all these things, right? That's called actually, you can think like that's a high level interface. The implementation is the class where actual home come and places there. They will start building the home on the layout that you designed, right? They will paint the on the ground actually a layout, right? First actually they will put that threads, and then they will draw the lines, right? Like how they want to build the home. That's what actually the interface you can think of, the blueprint on the ground. And when they dig it and when they start building it, that comes as a classes. That's called implementation of that interface. Next one, algorithms. Algorithms actually, you will know eventually like what algorithms we will be using. There are numerous algorithms to store the data according to your need. Okay. Now let's look at like what is the collection APIs. In collections, actually, as I mentioned, the superclass is collection. This is what actually we will learn about. The dotted line actually here, every box with a dotted line is called a interface. A implementation class is with the implementation class is with the solid lines. Okay, so collections, collection is the superclass of all your collection types. There are many collection classes actually in your design, not only listed here. There are many actually. I just took like a simple the daily use, mostly used collection classes here. Collection is the superclass of all the one. Iterator actually produces okay. Map also a collection. Again it divides. Iterator, list iterator will leave for now. Okay. We'll see like what is collection. Okay, what is collection? We'll see about this one. Okay, we'll leave for now actually the iterator. Also, we'll leave for the time being this map area. So first look into collections. Collection is a interface. It holds set of instructions to be implemented. And here it comes list and set, two types of there. What is list? What is set? We'll learn about now. As I mentioned, right, list. What is list? It can be anything actually that stores similar data. I mean, entire collection is similar data. So list is one of type. So for example, as I said, right, your wedding invitation list or your to-do list. What it contains all the data that is required, what you need to do it in the to-do list or your subject in a list. So it's a list. Okay, if you are going to a grocery store, most of us, right, will prepare a list. I don't know like how people memorize, but mostly people will put in a paper or they will put in note in a their phone and then go there and they will take it. So it's that's what we do, right? Maybe not, you guys may not be doing a on daily basis, but you will eventually be doing that at least 1 or 2 times in most of the times. Let's say actually you are going for a you are organizing some event uh, in your home. So you need to contact a catering person. So what you will do, you will give a list of items, what needs to be there in the catering. So that's at least, you know, that part, right? So there should be a sweet, there should be rice items, there should be starters and all. Actually, you will put them in the list. That's called, this list is something like where you can the list of examples are for a menu list, wedding invite list. Okay. Grocery list, anything actually can come there. Again, this is the interface only. They decided, okay, when they are developing, when they are developing, they decided Um, collection is one set of instructions and list is another set of instructions where it can hold that where somebody needs to implement it. So now actually if we see, there are two sets again here. List, there are two sets again, set and list. The difference between list and set is pretty much, the main difference is list can hold duplicate values. It can hold duplicates. Set cannot hold duplicates. That's what the difference between, the major difference between list and set. And list has the implementation comes in ArrayList and linked list. And set comes up, the set has an implementation like has set and tree set. We'll know like what and all actually in now. So what's there in the contract? What's there in the contract? What is there in the actual collection? And where I said actually collection, what will be there in the contract? In the contract, actually, they will define only fundamental methods. Like what is my size? Like this, empty. Is this collection is empty? Or so what will be there in the basic methods, right? What should be there when you are implementing a collection, right? So think that actually when you are building a home, what are necessary things needed, right? Maybe like how the water comes in should be there. There should be a water in, and there should be a sewage out, that there should be out, and there should be electricity connection should be there. These are all the things actually where you will define that how those connections will come into your home. And that's where actually this is one type of instructions where it came. Another set of items, right? Maybe very specific. These are like when you are building the home from the municipality, what you need to get the details. That's what actually there is in the one list one. Like very basic information like a size, is empty, contains, add, remove, iterator, etc. So let's look at once actually what is there in the collections. Yeah, see, this is what actually collections. I'm going to the Java doc for each and everything. So again, it's like a field summary. They mentioned it. What fields it will be like having map and all. Yeah, these are all like a methods. Add on as a list of queue. Binary search, checks collections. These are all actually they gave the method. At very least, actually empty list.
Not
These are all
showing.
actually. Okay, 1 second. Can you see it now?
Yes, sir.
Okay. Yeah, thank you, Sabha. So see, actually, these are all actually which will return the default implementations, entry set and all, right? These are all actually will give you a default implementation list. Uh, so these are all the things actually where they provide all the methods in the interface. So what actually you can see that in the future. So similarly, collections. Similarly, look at the util list. Look at that, what methods are there. So list is more like a your specific, because you are how you are adding to a list, how you are dealing with the list items, and all will come like a more specific to your the list structure, iterators, all these things will be there in the this one. As I said, right? Yeah, size, sort, these are all the part of the more what should be there in respective of the implementation, what should be there in my list, actually that should be there. So you can see that known subclasses here, like array list, linked list, vector. We'll learn about that one eventually. It's not about the PPT, whatever I declared, I showed it. It's possible, everything. I mean, there are many other classes also. We'll show that. Okay.
Sir, I have a dot here. Array list
Yes,
linked data structure. It's come in collection, sir. It's an
right.
okay.
It comes in array list data. Most of, I mean, as its name suggests, right? Most of that related data, how to store, how to deal with that one, comes in collections. And again, see, look at here, this one, the package structure. All these collections will be part of this java.util. So any collection actually is part of this java.util package. Again, what is the package? It's a logical segregation, right? So all the package, all the collections is part of the java.util package. So now actually let's try a sample program, uh, uh, how you can store the data. Okay, so how we can store the data? We will try with a sample program. I'm creating the package so that actually you can remember it, what need to be. So first we will learn about ArrayList. So I'm creating everything in a main method. So in order to use ArrayList, first we'll know like how ArrayList is working, then we'll learn the deeper implementation. So in order to define the ArrayList, right, what I need to do, I need to import the necessary class because it's not there in our class, right? Java.util.ArrayList. This is where what actually will be using it. So ArrayList list equals to new ArrayList. This is what actually you can use this one. You need to declare it. So here, as a collection, you can start adding it any elements. Maybe add sub. Like if I want to add a list of students, I can keep add all the names here. So likewise, actually, I can keep on add the names. Okay, and likewise, actually, I can keep on add the names to the collection. The add method here is provide add method will be used to add an element to the list. That's what add method part is. Now, right, how I can read the data. Now add is okay. So collection is all about actually what? Storing. Maybe this is what add is nothing but storing, reading and manipulating, right? How you will read the data. So to read the data, so first actually, yeah, let's look at one more method, size. Right? So how many elements are there in my list? I want to note down that one. So it provides, there is a method called size. Just like your array, right? Array dot length. So it stores, it gives the size of the list. So let's see actually if it gives the right size or not. Just 1 second. What? Okay. So list dot size will provide how many elements stored in the array. Size of the list size of the list or how many elements are there in the list. That's what actually provide. So let's look actually whether it's providing the details. Yes, I stored all the data here, right? And I stored all the data and I'm able to print the size of the list as well. Okay. Now let's look how this add will store, how this add method is working internally. To do that one, because it's an array list, let me first actually do how I store the same data in array. If I want to store the same data in array, right, it can be, let's say, as I'm storing all the data in strings, what I will do, string, this is the way I will declare array with square brackets. Okay. Student list equals to new string. Here I need to specify the size. If I want to define, if collect array list is not there and I want to display everything in a collection of array, so I should specify like a 5, right? And I need to display each and every time I need to go by index. First index starts from 0 equals to sub. So likewise, actually, I need to keep adding all the elements to my. This is the way I can store the elements in an array. So what happens now if I store these elements now? Let's say it will create so what happens here, actually it will create a table like this. Okay. And each and every, when you say like a student 5, right? So what happens here? It creates 5 memory, it creates a memory location and it splits into 5 uh, 5 sides, actually, like 1, 2, 3, 4, 5 boxes. Similarly, actually it will store that one. Let's say this one may be a memory location. Let's say it is some memory location. Okay. A, B, B, C. So this is some memory location. In some memory location, it creates 5 spots that can hold the memory. So here, this is what actually it does. This piece. So this piece will create in the memory like this. And now every piece is actually, yes, segregate. Everything is actually stored in index. So how you can put that index is, first one is 0, second one is 1. So it starts from uh, 0 actually. Always the indexes starts from 0, 3, 4. This is how actually it stores the data, 0, 1, 2, 3, 4. and everything is empty here as of now. Now, when you put like 01 is Sabha here, so what happens now is this 0th location, you are putting Sabha over there. Sabha will come and sit there. Initially, it is empty. For example, here it is in the 2-3 cases, right? It is just empty, or you can also call as a null. Initially, it will be empty. So every time you keep the data on that index, it will put the value. So for example, let's say actually I want to give student list of maybe 1 equals to Shika. What happens here earlier, Madhuri was there. When I give this 1, right? So what it will overwrite the data. It will wipe out this data. It will wipe out this data and it will store Shika over there. Like that, actually, it will overwrite the data. So the in array, what it matters is position is a matter. When you define the size, it creates a appropriate collection where actually it can hold that much data in your memory. So it is something like you are placing. Let's look at like a your wardrobe closet or anything. So if it is a sari, you will keep in a place. If it is a dress item, you will keep in some other place. Within your wardrobes section, right, you will segregate it according to the size, how much it will take it. So based on the size here, right, it will allocate some memory and it will give a standard size for that one. So for example, you change your mind. No, it's not for me actually 5 is not enough. I want to increase that to 10. Then the problem comes. It cannot actually expand it. Right? It cannot actually expand it. What it has to do, it has to recreate the entire structure and copy them. So array list, that's in array actually that's the biggest disadvantage. When you define a size, you can't actually expand it. So let's say actually you define 5 size. Now you want to add the 6th element. Sixth element, maybe let's say here it will throw a index out of bound exception. Why you will get index out of bound exception? Because you defined only 4. So you define only 5 size and you are accessing on the 6th element. So there is no index that one. Index is overflow. The maximum index you can use is 4 only because it's a 5. Again, it starts with 0, that's why 4. If you want to use the 6th position, it will throw an index out of. Let's see that how it will throw it. See, I throw it. Array index bound of exception. If we don't do that one, it can store all the data. It stored no errors. If you want to read particular data, right, from the list, actually, you can write by accessing the index only. Let's say I want to add a 2nd position. Yeah. So though actually we created Madhuri here, it is overridden. If I don't specify, right, it will print Madhuri. likewise the array will work. So if I want to increase that in the, when you declare the size, right, you can't actually increase that size. There is no way. Similarly, if we don't specify a size element, let's say the last element you didn't specify. So what will be the output? It just prints a null value because it contains a null there, empty. Null means empty in Java. If you are any other programming languages, it's also called a nil. Maybe in Swift or any other programming language, it's called like a nil or null. Most of the programming languages, it's null only. Okay. This is the way actually how array will work. The underlying, it's actually tedious, right? It's though it is useful in your program, it's kind of a tedious job for you actually to store all the elements like this, and because it does not have a expandability, elasticity. If we want to store more data, it cannot store it, right? So it has its own limitations. So what Java developers thought, okay, it's a good idea. Why can't we implement similarly, instead actually giving to the developers each and every time? Why can't we give the boilerplate code? Boilerplate code means actually how it is implementing. They will do this implementation and give it to you. That's what a boilerplate code calls. Okay, that's where actually the ArrayList born. ArrayList is exactly works like a array, but only thing is, instead of specifying you here the name, it works. It internally takes care of the add method. It internally takes care where that particular element has to go. Okay, it always have the next element. When you say add, right, it always goes through the last element and adds that one. So let's say now in ArrayList example. So far, any questions in the array? Sorry.
No, sir.
Okay. So if you are okay, let's look the ArrayList portion now. So when you define array, right, what happens? So it, as I mentioned, this is a pure array implementation. So what Java developers did, you can also go to the source code, but let me explain here. What Java developers did, they creates this one, yeah, not 5 size, but they will define an array of 10 elements. 2, 3, 4, 5. So it also has the indexes. So each and every place, it also has an index. So it also has the index actually, how it can, this is what actually this first method will do. Our new array list, again, very, very important. Many people will ask you, note down this one. Array list by default creates an empty array of 10 elements. The size is 10 elements. So you can also see how it is there. I'm going through the source code, how it is used. So this is what actually you will use, right? In size. Okay. Default capacity is 10. The array list, when you say, this is what actually the public constructor will be using it. See, this is a polymorphism, overloaded constructor. You can specify a capacity, or you can no need to specify a capacity. So if you are not specifying the capacity, what it is going to do, element data equals to empty element data. So where it is coming from? See how they organize. It's an array. It's of type object. This is the way actually we'll declare the array, right? It's an array. Okay, so it actually provides, I mean, the implementation actually, maybe if I navigate all the code, it's very difficult for you. But actually, let's look this one. The default initial capacity is 10. That's where actually I mentioned it. When you declare array list, it creates the default initial capacity 10 elements in the memory location, wherever it is. And then you can keep add the elements. So again, like a previous case, right? Sabha will go in the list 0 because the first element is coming here, Sabha, right? So how it works? So here in this box, Sabha will go. Okay. In the next box, Madhuri will go. In the next box, Surjana box, Hari, Shahid. This is how actually they will be going into each and every uh, box of items. The remaining will be unused. Okay, let's say you are adding a sixth element. Here actually it will go. Let's say I'm adding a sixth element now. It will, Shakira will come here. That's how it will work. For example, there might be a need that you want to add at a specific location. This add has a different implementation also. Add list dot add. If you see here, it is giving you a hint, right? The editor. That's why we use the editors. Okay. Add, the first one is directly we are adding. Second element, we are adding at a specified index. Okay. So in the second one, we are adding at a specified index. So let's say if I want to add an element, not at 6th, I want to add at 8th position. Yeah, we can add it. This is the way we can add it. So let's say now after adding, what will be my list? That may be curious, right? So let's see what it prints the list. Okay, so it's throwing that. Yeah, so it is throwing because the list element, though actually you defined that 6 elements, the 8th position you are adding it, right? That means here it is throwing the size is only determined till 6, not at 8. So it's throwing the error. So if I want to add, let's say if I want to add at 2nd position, I can, if I add it, there shouldn't be any issue. So totally 7 elements we have added. I think there is a implementation change. What I noticed technically in the previous case, right? It should not throw error because it has a 10 size. But even when I notice it, actually this default size is not used anywhere. Let's see the same thing with 10. Okay, they are calculating the size. Okay, so you cannot add any size there. You cannot add any size there. Let's say you can add maybe 6th position. You can add then it is same as the present position now. Total size is 6. So if you want to add, this is 0, right? 1, 2, 3, 4, 5, 6th position, you can add specifying the size. Or you can, if you add same element, let's say at 6th position, another new name actually you are adding it. Let's say that is Kavya. You are adding at 6th position. So in this case, what happens, right? It just overrides whatever the old value, it wipes out. Let's say earlier it is Dharani. Now it's wipes out with Kavya. So let's look that one. This is size item, right? How you will store the date, how you will determine the size of the list. Similarly, if you want to read from the data, how you can do is, let me put that in a system.out.println. List dot, there is a method called get at what index. Similarly here, like whatever you saw that, right? Here in this case, like a 4th index. So the get from which index actually you need to read the data that will return that particular position, whatever the element placed in that particular position. Let's say I want to read at 6th. Now what will come? Kavya will come because it's Dharani is overridden by Kavya. If I don't have it, obviously Dharani will come. Okay, so that's how actually the total size will how it will store the data. Not only that, also actually here you can delete certain elements. Let's say list dot remove. You can remove by index. So I want to delete at line number the position 6th. and let's see like what happens to our size after deleting the item. So this is what this line, and I deleted a sixth element, Dharani. Now the size became 6. It's actually wipes out the data. So when you say delete, it just wipes out this data and keeps that empty only. So for any questions on add in the list, how the array list will behave?
Sir, can we use sort function?
Yeah, I will go there. If you want to add more than 10 values without defining, then no, mother. If I want to add more than 10 values, that's the advantage of the list I'm covering now.
Okay.
So let's say actually you want to add more elements. List.add. Now let's say you are adding mark. List.add. Steve. List.add. Thomas. So we have completed 10 elements now, right? What is the size? Let's see actually without removing. We have the size called 10 elements. Now if I want to add another element, that's the advantage of this one, array list. Whereas in array, it will throw error. Now in case of the Java, right, it provides expandability. So list.add will provide, let's say now I want to add I want to add one more name, right? So now in this case, what happens, right? It still adds that size. First run this one and then I will explain. It should not throw any error. So the list size is 10. My initial capacity is 10 here. Right? I explicitly specified for this example. So, and then I'm adding the 11th element. So it should not throw any error.
Okay, sir.
Yeah. How it works without throwing? You might have question. So what it do, right? It's actually a complicated operation. So every time you add more elements, there will be like a concept called like how much it has to grow. That's where actually look at documentation in this case. Factor. Okay, I just told one thing wrong. Let me correct it. First thing is, let's say if we are adding like this, right? What it will do, it will just shift the elements. Let's say look at, it's not override, it shifts all the elements to the right. So earlier actually here, Dharani was there, and actually you are trying to add Kavya here, right? So what happens, what happens is if you are trying to add sixth element, actually will move to the next seventh position like this. Okay. Now Kavya will come here. Okay. And Dharani will come here. That's what I can notice it. Look at here actually. Sixth. Let's run this program and verify that. See, when you are adding, it will just shift that one. So similar, the list also became 12 size. So it will not override the values. I'm sorry, actually initially I told it's override. It's actually shifts the values. What happens, how it works, right? So it provides the default mechanism of expandability from the initial capacity. So whatever the initial capacity you created, it actually what it does, it actually creates a new structure with a growth factor. Let's say you created like a 10 size, right? So as soon as actually it comes to 7 or 8, actually it automatically increases that value. I mean, I want try to show you here how it works in the Java program. See here, grow method. Every time actually we're adding a new member, it's actually growing that. And then it's doing a copy. It's copying the data. So what is copying means? Let me go here. So you first created here 10 size, right? And now you are going beyond 10. So what it does, it creates another set to accommodate that size. Okay. Another set to accommodate that size like this. There will be like a for like when growth factor or something like that, there will be there. Like when the 7 element came, right? So it starts growing it, maybe like another 5 elements. When it reaches 12, again, one more 5 elements. Likewise, actually, it will try to increase the capacity and reserve it for you to add the elements. So likewise, actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's say in this case, my growth factor is 5, right? So it will keep increasing the size and all these elements, right? Whatever you stored here, it will be copied into this one and this will be deleted. This will be deleted and all these elements will be first copied to this one. And this will be deleted. A new array list of new different size will be there. That's how actually Java will manage the array list. So instead of you struggling, Java will create and give it to you.
So
Okay.
ArrayList is
Any
dynamic in size.
Correct. Absolutely right. ArrayList dynamically increases the capacity according to your need. As number of elements are increasing, though there is an initial capacity, the initial capacity actually when it reaches to a certain level, it actually try to increase the capacity again.
Okay.
Okay. There is no fixed capacity, right, in ArrayList?
Sorry, what's that? Sabha, can you repeat?
There is no fixed capacity in ArrayList, right?
Correct. Correct. There is no fixed capacity, but there is initial capacity. But it can increase. It can that elasticity is there in the array list.
Okay.
So array is static and array list is dynamic. It's the major difference.
Correct. Array is right. You are absolutely right. Array is fixed size.
Yes.
You cannot increase the size, and you cannot shift that one. Like for example, actually in this case, right, you are adding a element at 6, right? You cannot actually shift that position. So
Sir,
that's
I'm having
about,
one more question.
yes.
Can array list support generics?
Yes. I haven't done that one. Yeah. So it supports, I mean, that's the reason actually we went to generics class as well, right? So if I say specifically string, right, as the collection says, it has many, when I don't specify, right, I can store any data here. List dot add 8. Maybe I can add number also, right? But this will have the problem in future implementation. Like when I was doing all the strings and all of a sudden a number came, is 8 in name or 8 in name or number? How can I distinguish it? So that's why actually generally, right, I will define the generics here. What needs to be there so that it's kind of a fail fast mechanism where uh, where I'm giving to the developer that, okay, boss, it is declared as string. You cannot have actually integers passing here or any other objects actually passing here. So that's what it will tell that. So any other question on the array list?
Can we store primitive data types?
Yes. So primitive data types again comes up with wrapper classes. Every class has a wrapper class. Right. Every primitive data type has a wrapper class. So in this case, right, see, look at this one. Except integer, all other elements turned into errors. Now, okay. Any other questions on so far? Now let's go back here. Yeah. Yeah. Who is that? Is that Sabha?
Yes.
Yeah. What's the question?
Nothing. I said no.
Okay. So now, accessing the elements, reading the elements, we will see it. So every time actually get actually is a problem, right? You can't actually know like what's the index. There should be a mechanism where you can see without accessing index all the elements, or there should be another way actually where you can see all the elements. So that's where this iterator comes. Earlier we learned about this iterator, right? So iterator is actually you can think like a crawler where it will go and read all the elements, that kind of mechanism, right? Let's say actually uh, you are in an exam hall, right? Your invigilator will take the question paper and distribute to you like a step by person by person, person by person. That functionality, like visiting each and every element, that is what actually comes in the iterator. Again, this iterator, they put like a separate functionality, as I mentioned earlier in the previous class, like a one bank accounts actually. One set of people are working in one list, one kind of contract, another set of people are working another set of contract, right? So collection, the iterator is what actually the collection, the list class implements both iterator contracts and collection contracts. So look this one, like how it is defined. The class declaration, array list, array list actually extends abstract list. Okay, so look what is or else actually I can go here. Array list extends abstract list, abstract collection. Okay, if you go abstract collection, it's actually implemented interfaces collection. Abstract collection implements the collection, and it is abstract list is what that subclass, and it also implemented the iteratable interface. It also implements the iteratable interface along with the list interface. So two interfaces are there. See the definition: abstract list extends abstract collection, implements list. So all implemented interfaces are collections, iteratable. Where it is implemented, extends iteratable. See, the collection itself actually extends iterable. So this provides all the mechanism. Iterable provides all the functionality that needs to iterate like each and every person, like your invigilator distributing you a question paper in the exam hall. So how we can iterate it programmatically, how we can use that one. So when you do list, right, dot, here actually it provides all the available functionalities. So here there is a method called iterator. So this will provide the interface for you, like how you can iterate. So iterator. So I define the iterator. Now you have the iterator. Using this iterator methods, you can visit each and every element. Yeah, okay. So now let's see this one. Again, list iterator. I just named that one. So has next. That means whether the element is reached end of the element, this returns has next will return if visiting reach end of the list, then it's true. No, false. If it is not reached, right, then it will be true. Means there is a next element. Has next will give you, as long as there is a next element, it gives true value. So think about our loops now. If what I need to do, I need to visit. Okay, there is another element. There is another method also. Let's see actually. Next, what this do will return the current value wherever it is there, right? Wherever it is there, that current value it will give. So actually, let's say so you want this way. It does not matter how many elements are there, right? So your iterator actually first will be so it will be here in the beginning. Has next, right? If your list started here, right? So list dot iterator will give list dot next will give you whatever the elements it is there. So for example, the element here it is yes. Yes. So the element list dot iterator next will give the current element. Has next will give you whether the next element is null. If it is null, right, it just simply returns false because there is no next element. Okay. And next element will give you that. So by using this one, right, these two methods, you can think of like how you can iterate till the end of the list. So one way is all you need to go every time to the next element and read the value. So you can use while list iterator dot has next is will give you a mechanism to navigate till that one. And what will you do here? So I'll comment out these two and see what happens now. See, it's printing all the elements. Let's say now. Is printing all the elements from here. All 12 elements should be there in this one. So that's how it will work. So first actually it will be has next. When it reached last element, right, it returns false. Then what happens? Our while loop will end. That's one way actually where you can use the. I mean, there are many ways actually where you can use the iterator. You can use even in the for loops. You can use just 1 second. Yeah, I'm back. So it will there are many ways actually where you can iterate using the iterator. You can use for loop, you can use while loop, any ways actually you can use that one. Okay, but I am also covering the advanced features now. Yeah. So this is one way, iterating through the iterator, but the Java for each loop, another way is, okay, same thing I can iterate for int I equals to 0. I am declaring I equals to 0 here, and I know like where my size comes from list dot size. Till the time I less than size, yes, and then I plus plus. What I'm going to do, simply I am iterating it using a native method like a list dot get of I. I is my index. So every time actually I am moving the advancing the element, I am getting it. So this is one way. Next comes up the for each loop as well. This is for index loop, right? For each loop. So in this one, we will not have this one. So for each, the target element is list here. What you are iterating, what you are getting is string, and then you need to typecast it name. Not typecast, you need to give the variable reference. So what it does, it internally implements the iterator logic. It internally implements iterator logic and assigns the variable. So this is also one way actually where you can iterate. So let's see the results. So for each loop, we are getting all the elements. Through index, you are getting all the elements. Likewise, actually, there are many ways according to your need, which will be best, you can use it. From Java 8, this is actually Java 5 onwards. Java 5 feature. From Java 8, it also introduced a concept called streams. Just stream means streaming the data. Like you have a river. River is what? A stream of water. So same way, collection also you can stream it, like a flow it, and then do it. So here the same thing how I can do it. List dot the method called stream that opens up a stream of flow. Then what you can do, there are different methods. Today I will cover again here for each layer. So where you can use this one. So today, in order to print, I'll use map. Map is nothing but how you want to do it. What I will do, system. Okay, let's try with the for each basically. So this for each, right? You don't need to declare a string or anything now here. Like this all this one. Now actually it comes up name. You can give like any name or like a any name here, and then followed by a operator called lambda operator. Okay. Here you can simply pass what you need to do with that. Enter any name. So this logic is trimmed to one line. This 3 lines of logic is trimmed to one line as this one in the Java 8. So it's simply stream. Actually, you are opening up a stream. Okay. And then for each, you are telling that to implement this logic, okay, by passing this name here, right? This name, and you are passing this one in a lambda function. The block, I mean, you can implement the block or anything. Actually, you don't need to implement the block. To implement the block, you need to have a colon here. So it's almost same thing. Okay. Yeah, iterating through Java 8 for students. So this is the way actually you can iterate it. So there are, as I said, right, there are many ways where you can iterate the data and read it for your purpose. 1 second. Give me a minute. I need to make a call now. Or else if you want to take a break, a short break, 2 minutes break, you can take it. We will regroup again in 5 minutes. Okay. Just let's take a bio break, then we'll continue again in 2 minutes. I'm
Okay, sir.
stopping my recording here.